When you want to do something with infrared diodes or infrared measurements, and you only have, say, salvage components, it's often not easy to find how to connect, wire in all these infrared sensors, and not only the sensors but also the radiators. With infrared measurements or circuits that activate something with the help of infrared, there's always a radiator that sends out an infrared a frequency in the infrared band, and there is a detector. And here you see all kinds of components of which is not sure how to wire them in. What's the positive, what's the negative, etc., etc. And this video will perhaps help somewhat. The whole idea was this. I had this beautiful book, McMurray, all about chemistry, and wanted to do an experiment with infrared light, in which I could try to find an absorption band, only one, of a certain chemical substance. And this is the complete infrared region. And of course, from all the components that I showed, I don't know where in this frequency band they send out that infrared energy. But I will talk about that later. This is, by the way, the principle about how this, say, chemical analysis method works. In the molecule, there are bonds between the elements of the molecule, and they can stretch in certain ways and vibrate. And in chemical literature you find, for instance, for this distance a certain value, say in the angstrom range, so very tiny value, but that is in fact a general value. And in fact these bindings inside the molecule vibrate. And the best idea to study that, get insight, is the comparison with a spring. So it's a kind of spring here, in a popular way, of course. And when we send in a frequency in the infrared range, some bonds, according to that specific frequency, are affected, and that gives absorption. So in fact, you see, for instance, here an infrared figure of the absorption when we send in this frequency band in the infrared range from this value, wavelengths in micrometers, so it's radio technology, but it's in a tiny frequency range, and I mean the frequencies are very high. Between these frequencies, when we say sweep that whole frequency band in the infrared range through the, in this case, ethanol, we see absorption on certain frequencies, and this gives a characteristic pattern of ethanol. And of course other say substances that can be measured in this way give another pattern. And there are books with, say, thousands of patterns of all kinds of substances. Anyway, I only can give an idea. I don't know much about it anyway. Here we are again with these infrared LEDs. This is an infrared LED that I bought, and I know that it worked between 920 and 1000 nanometers. So from this LED, infrared LED, I know the frequency where it operates. And I'm more or less sure that all these, say, radiators here, there are not only radiators, but anyway, are only sent out in a certain frequency. So to get that sweep, that will not be possible with this setup, but anyway. By the way, this is an infrared sensor, a PIR sensor, and this is out of an old laboratory equipment, and I'm sure this sensor can measure a big range in the ultraviolet. Zeg ik het goed? No, infrared frequency band. This is a good sensor, and also this one. But okay, let's get back to the schematic. What you can do when you want to figure out how to wire in that component. At first measure the radiator and the detector as if it is a diode. So take your Ohms meter and measure where in the component is the cathode and where is the anode. I have to say, some of them measure very clearly that it is a diode, but other ones don't measure that so clearly. But anyway, it's the best idea to do. And then, of course, take a normal diode, do the measurements, reverse the positive and negative of your analog meter. That's the best meter to do that, because it has a 3-volt battery inside. It has to have that to get over the barrier voltage of the diode. So then you can measure how the current flows in the sensor, both in the sensor and in the radiator. Then you know how to connect the diode. Because when we connect here a positive voltage and here a negative, a current starts to flow and the radiator sends out in the frequency band, in the infrared frequency band. So that's for sure. Very important, always use a 1K resistor here, because never connect here directly a voltage source, because of course the diode can burn out in that case. It's very important. And then on the other side of the circuit, the detector, and the detector is connected to the Ohms meter, and in such a way that the current is as low as possible, so that the meter does not move. That's the way to do that. But when the detector receives the infrared light, the diode will also start to detect, or the other type of detector, and then a current starts to flow, because here's a battery in the meter, and we see the pointer move. I want to do that now, and I use for that purpose this remote control. It has an infrared LED, and you can see that when you push the button, digital cameras can make infrared light visible. That's clear to see here. And here is a sensor. It's hooked up to the meter, and when I shine that not visible infrared light to the meter, we can see the pointer move. Little bit, yeah. So that's clear. It's clear to see in this way, with the help of that remote control, what is the sensor and what is the radiator. So that's a good way to do. I have to say that not all these sensors that I have here, this one for instance, and this one, they are of course not all made for the frequency on which the remote control works. So, could be that when you do here a measurement in the way that I've showed, that you don't see any movement in the meter, on the detector. So this is a broad range detector, and it must work on all kinds of frequencies in the complete PIR spectrum. So this one was for instance sensitive for the frequency that was sent out here, but this one was not sensitive for that, but it is a kind of array. It is of course sensitive for the frequency that is sent out by this infrared LED diode. This is a detector, of course, and when the light is blocked in between the signal at the detector disappears. That's the aim of this electronic component. And here more or less the same. I see here two very bright lenses inside. I don't know exactly where it was made for in the past, but anyway, it's a usable component for experiments or whatever. So that is more or less a good way to find out which component is a radiator and which component is a detector. It has kind of diode properties, both the radiator and the detector. So here are all the attributes that you need to do these tests. Anyway,